Hello, welcome back to another lesson. In this lesson, we'll be considering secure software development. This lesson is going to be focusing on how secure software development reduces risk by building protection directly into code from the very beginning. Security is not something we add later. It is a core part of how software should be designed and written. So let's get right into it. Why does secure development matter? It matters because most security problems start in code. Many vulnerabilities are simple coding mistakes, and fixing the issues after deployment is very expensive. Security bugs can scale quickly across users and systems, and secure code reduces the overall attack surface. What is secure software development? Secure software development is a mindset and a process. It has to do with a situation where security is built into development workflows, where it is not added at the end but at the beginning, where security is treated as a requirement and not an afterthought, and where responsibility is shared across teams. What are the common causes of insecure code? Insecure code often follows predictable patterns such as trusting user input, poor error handling, hard-coded secrets, and insecure default settings. There's something we call shift-left security. So let's consider that. Shift-left means moving security earlier. It's just like moving a bit back, trying to consider security earlier and not later. It means starting with security early in development. And if we do that, issues are going to be caught before deployment, and fixes are going to be faster and cheaper because we are considering them early, and overall, the software quality would improve. What are the secure coding principles? Strong code follows clear principles such as least privilege, input validation, proper authentication and authorization, and secure error handling. Let's consider input validation and sanitization. User input is always untrusted. So we should never trust user input. We should validate data type and length. We should sanitize before processing, and this would help us prevent many common attacks. Let's consider error handling and logging. Errors must be handled carefully. So we must avoid exposing sensitive details. We must log errors securely. We must show generic messages to users and not the real error log. And we must keep detailed logs for developers. That means that the detailed ones, those ones that can be very, very long, lengthy, and then detailed, we should keep those ones for developers. So users can just be seeing page not found, server error. So they don't really know what is happening, or they don't really know what the error is behind the scene. They are just seeing a particular page that is well designed and that is showing them that, oh, there's an error here or there's something going wrong here. But they are not going to see the exact details that is coming from the library failing, the server failing, the application failing, the endpoint failing. They are not going to see those details. So let's consider secrets management. Secrets require special protection. That means that we should not hard code passwords or keys. So don't hard code API keys or some passwords in any part of your code. There are ways to handle that. You should use secure storage solutions. You should rotate secrets regularly. So if you are generating an API key now, or you are generating a secret key now, ensure that you rotate them maybe on a monthly basis. Depending on your company culture, regulation, or policy, you should rotate secret keys. And lastly, we have limit access to secret keys. It shouldn't be everybody that would have access to that. And sometimes when you are pushing your code, maybe to a repository that every developer in the organization contributes to, ensure you do not put the environment variable file that is containing all of the secret keys, because inside that file we can be having the key and then the respective values. It should be excluded. If you're using GitHub, you can use git ignore to separate that so that the rest of your code will be going to the repository, but the file containing sensitive details or sensitive credentials are not going to be pushed alongside your code. Let's now consider dependency management. Vulnerabilities. Third-party code introduces risk. That means libraries may contain vulnerabilities. Risks can from there spread quickly across systems. And this means dependencies must be kept updated and known issues should be monitored continuously. Now, what is secure code review? Reviews catch problems humans miss. We can review logic and assumptions. We should look for security flaws almost every time, not almost every time, every time. We should share security knowledge across teams, and we should catch mistakes early. So these are like things we consider when we are doing secure code reviews. Next, let's consider automated security testing. Automation strengthens security at scale. So when we are considering automated security testing, here are some of the components. The first one is static analysis. There are tools that we can use to statically analyze codes. Also, we must do dependency scanning. That's another component of automated security testing. And continuous integration pipeline, that is CI integration. We should do that as well. So security should be embedded in all of these pipelines too. And we must continue to do security checks on a daily basis. Let's consider secure development and the CIA triad. Code quality impacts core security goals. Confidentiality is impacted through proper access controls, integrity through validated logic, availability through resilient design, and all three depend on secure code. What are the real world impacts of insecure code? Insecure code has real consequences such as data breaches, service outages, financial loss, and reputation damage. So in this lesson, we've learned a couple of things. We've seen that security starts in code, fixing issue early saves time and money, secure defaults reduce risk, and developers play a critical role in secure coding. Let's take a test together. Here is the question. What does shift left security mean in software development? Pause your video, read through the options, pick your answer and drop in the comments, then come back to play the video. What's the correct answer? C. Integrating security early in the development process. That's all for this lesson. If you're yet to subscribe to our channel, please do that now. Kindly like, share, and comment as well. I personally want to know what you've learned in this lesson. So drop that in the comments. Thank you, and see you in the next lesson.